Ars Electronica home delivery. While you can't come to us, we come to you. So I'm really delighted to welcome you for this next session here, live from Deep Space 8K at the Ars Electronica Center. My name is Michaela, and for this session I've prepared something really special for you, a special technology called cinematic rendering. And possibly you are already acquainted with this technology if you have watched some sessions from Deep Space already. So, cinematic rendering is a wonderful technology. It's a pairing, a marriage of two technologies from totally different disciplines. First of all, you have imaging procedures in medicine, like computed tomography or MRI, for example. And normally, when you stack all the sections of X-ray images, for example, you can create a 3D volume model. But of course, this would not look photorealistic. X-ray measures the density of a material, and as you all know, X-ray images are black and white. Now, cinematic rendering uses rendering technologies from the entertainment industry, and that's the interesting part of it, because in entertainment industry, we all know this, we're watching films, and artificial creatures look totally realistic. And if you combine these two technologies, you get photorealistic insights into the human body, but not only. So this will be part of the presentation now. First of all, let's start with this here. So we have the head of a patient. You can see I'm having an Xbox controller in my hand. And with this Xbox controller now, I can navigate and control the image that is projected onto our 16 by 9 meters projection area. So I'll show you. So the data here, the scientific data, are analyzed and interpreted by this cinematic rendering program that was, by the way, developed by Siemens Healthcare. And when I turn the patient to the side here, you can clearly see here in this section, this is an X-ray image. That was a computed tomography. And now I can, for example, cut a bit deeper. So you can see layer by layer of the X-ray image. And now cinematic rendering analyzes the about 3,000 shades of gray on an X-ray image. Shades of gray that the human eye could not perceive, of course. And it interprets it and knows which material we have here. So let's put the shoulder back. You see, whenever I move the image, it takes a while until the whole data set is depicted again, because this is an extreme amount of data. But now we have the image perfect. So, and when cinematic rendering then knows which material we can see, it also calculates the paths of light. And it depicts how light would behave on the materials, on the special materials. So, and this is the reason why light and shade are perfectly shown here. So, and what I can also do is not only cut into this 3D volume model here, I can also take away material. So I've taken away the skin now. We can see muscles, tissue. I'm going a bit further. I take away the muscles and the tissue, and in the end we have the bare bones here. We can see the arteries, for example, the carotids on the neck. And another great opportunity here with this program, cinematic rendering, is you can also depict false colors, like here. So the tissue and the muscles are green and blue now, and with this method now, you can clearly see the arteries and the glands, for example. So, and I'm just switching through some settings here to show you to give you an impression of what this program can really do. So now we have cut away the face. Sounds a bit brutal, so you see, but now you get an insight into the sinuses, for example. And what is really revolutionary about this technology is, before cinematic rendering, of course, we were able to create 3D volume models of scientific data, but never before you had such a photorealistic depiction of it. And the cool thing is, when I do sections like this, for example, the patient is totally unaffected because this person was in the computed tomography, and afterwards you open the data set with cinematic rendering. So, and with this, even layman, more or less, can make a diagnosis. So if something's wrong here in the skull, we have taken away, filtered away, the brain mass in this case. And what is left are the arteries in the brain, and something's wrong here. This is not the eyeball that will be over there. This is a so-called aneurysm, a widened artery, and it's filled with blood. And of course, this can burst, and this is an absolutely life-endangering condition, of course. And with cinematic rendering, surgeons, for example, can prepare a surgery because they can make themselves acquainted with the individual anatomy of the patient. Cinematic rendering is mainly used here in our deep space for lectures of human anatomy. And as you can imagine, this is a totally new way of learning, of studying the human anatomy, the anatomy of the living patient. But now, think of this. Computed tomography is normally an imaging procedure in medicine. But I'll show you another project here. But in the end, you can put any object into a computed tomography machine, like, for example, a teddy bear. And the same, what we did before, we can do now with this toy teddy bear. I can turn it around, I can have it a bit closer. It nods at us, nice teddy bear. I can take away parts of the teddy bear. Now, for example, the nose is taken away. Looks terrible, let's give it back. Or I can take away the fur. So, without using scissors or razor blades, we have a naked teddy bear now, and you can see the seams here. And if I take away a bit more of the material, the teddy bear is totally naked. And due to the fact that a teddy bear doesn't have a real anatomy in the inside, if I take away too much, the teddy bear disappears. So, but Ars Electronica wouldn't be Ars Electronica if we had not also the topic of media arts here. So this technology is really an interesting development, and the Ars Electronica also has a cooperation with the Arts University, namely with the Department of Fashion and Technology. So here in Linz you can study fashion and technology, and the students doing research and new materials. They already had some presentations here in our deep space. And also in cooperation with Dr. Fellner, who's doing the anatomy lectures here, they had this great opportunity to put their designs, their fashion designs, into computed tomography and then present it with this cinematic rendering program. So this is one of the designs of a student of fashion and technology. And now we can fly into it. And have a closer look. So the presentations of this course, Fashion and Technology here, were also combined with models and shows in here. And of course, it is a totally new opportunity for the students to present their designs like this, in combination with this cinematic rendering program, and give their designs a totally new, look, so to say. I can show you another project here. That's quite an interesting design that consists more or less of robes. And now we travel through design. And what's interesting with Nina